Number 39, it's multiple choice, but we still need to figure out how to answer it. And the multiple choice, remember, makes up half the AP test. So it's a good idea to figure out an approach to these without thinking that we're just guessing or we're just eliminating answers without any work. So they tell us that the volume of a cube is increasing at 24 inches cubed per minute, and the surface area is increasing at 12 square inches per minute. What's the length of each edge of the cube at that time? So if I go with the pig idea, the what is permanent, what's instantaneous, what do I have to get? A cube has all of its edges as x, so that's going to refer to the length of each edge of the cube, and those are what my 5 choices are. Nothing in that is fixed, except that they do tell us the rates that some of the things are changing. So a fixed value of dv dt is given to us, and a fixed value for dA dt, change in surface area, over time is given to us. And they're both positive, and they're both in the same units, which is nice. So what are we actually trying to get then? So we know what's permanent, we know what's instantaneous. We're trying to get, or our goal, is that we're trying to find what that edge is when those two rates are given, when dv dt is that and dA dt is that. So a different kind of problem. We have two different things that could tell us a little bit about x, and we're probably going to have to join those two ideas. So let's see what we can do with our dv dt here, going back to volume of that cube in the first place, which would be x cubed. So to get dv dt and an equivalent expression, we would come up with 3x squared dx dt's. Okay, I happen to know what the change in volume is supposed to be. I happen to know that at all times this is supposed to be 24. And change in side length x, I don't know what that is. So that's my second unknown. Back in algebra we learned if we have two unknowns in a situation, we need two equations that both use those same unknowns. I'm just going to solve a little bit so that I can have this one by itself. So I know that 8 is x squared times dx dt. Now I'm going to come over to surface area because I happen to know surface area for a cube is made up of 6 squares that are each x squared in area. So change in area over time would be 12 times the side length times the rate of change of the side length. And if I can move these around and have the same two unknowns by putting in that the change in area is always 12, I want to see if I can solve for one of these in terms of the other, and between this last one in green and this last one in red, I have a system. It looks a little different than we usually solve systems, where x and dx dt are my two unknowns, and I want to solve those together to find out what the actual length of the side is at this instant when both of these are happening. So I'm going to take this one and move it around a little bit. I'm going to get that 1 over x is equivalent to dx dt. So I'm going to do this by substitution and come up here and say, oh, well, then at that same instance, x squared times rate of change of x at that instant is 1 over x. I get that x is 8. So at the time when the side length is 8, that is when those two would have those equivalent rates of change. I don't need to go solve for dx dt because the only part of the question was, what is the length of each side of the cube?